I will now talk about some of the features and the potential applications for the new sensorless technology. Sensorless transient detection enables motor control and monitoring possibilities which are not possible with other detection methods, whether they are based on sensors or are sensorless. This is a diagram where we have shown the detector and controller functions integrated in the motor controller as they would be in a typical application. The orange box at the bottom left lists the standard features of DCM motion technology. These are sensorless rotation detection, counting and direction detection. In a system with more motors, you can also use these features for synchronous control of the motors. Now turning to the more advanced features mentioned in the large orange box to the left. These features require that the detected transients are digitized and analyzed in the motor controller. I'll just mention some of the advanced features here. Dynamic speed control, where the DCM controller algorithm adjusts the number of commutations or angular steps per time unit. Windscreen wipers, dynamically controlled in relation to car speed, is just one of many applications for this feature. The accuracy of the detection is determined by the number of commutators or poles in the motor. It is therefore possible to emulate a stepper motor with a rotational precision equal to the angle between each pole in the motor. For many stepper motor applications, this will be sufficiently accurate. Because of the angular accuracy of transient detection, a motor can be stopped or reversed with higher accuracy than most sensor-based systems. This can be useful, for example, for window lift systems with anti-pinch functions in cars. Analyzing the transient fingerprints for complete rotation allows for detection of aging of a motor, since the pattern will change with aging. This is useful for service and maintenance schemes and can also be useful for validation and quality control during electric motor manufacturing. At the moment we are experimenting with an algorithm that can turn off the power to the motor just before the kickback transient is generated and turn it on again just after. This would reduce the arcing and therefore the brush wear. The result is an extended lifetime of the motor and power saving. To demonstrate the basic features of DCM motion technology, we have built a DCM demo kit. A motor can move an actuator forwards and backwards, and the actual position is shown on a ruler. The motor is controlled by a linear power supply that is remotely controlled by a PC via a USB interface. Our DCM transient detector with a Smith trigger used as a counting encoder circuit is connected to the output from the power supply. The counting pulses from the DCM transient detector are sent to the PC via a simple RS-232 interface. For the PC, we have developed a user interface and a motor controller as Windows applications. The controller program picks up the counting pulses from the detector and uses them in a control loop to control the linear power supply. With this kit, we can set an actuator position and demonstrate that the actual actuator moves to the set actuator position both forward and backwards. We can also adjust all motor and control parameters in the system to encounter for different motor types. The list of potential applications for DCM motion technology is almost endless. This slide shows some of the areas which could benefit from our sensorless technology. From the discussions and interest we have had so far in the technology, the automotive area seems to be one of the most promising. This is because of the high number of DC motors used in modern cars. Some luxury cars have more than 100 small electric motors used for power seats, window lifts, windscreen wipers, wing mirrors and air vent actuators and many other comfort features. Automakers could potentially save a lot of money and weight if they didn't require external sensors and the many meters of sensor detector and sensor power wires and fragile connectors at each end of their control system. To go sensorless in areas where it doesn't compromise safety makes a lot of sense for car manufacturers. Battery-operated power tools, consumer electronics, precision instruments, various industrial systems, and not least toys, models and robotics are other promising application areas for sensorless detection and DCM motion technology. So to summarize my presentation, we have presented a new method for sensorless rotation detection in brush commutated DC motors. The new method, based on transient detection of the motor commutations, is a very reliable detection method, and it is simple and cheap to integrate with an existing motor controller. From our tests so far, the precision and reliability of sensorless transient detection exceeds the reliability of sensorless ripple counting. Going sensorless makes a lot of sense. It is cheaper because there are less components and it saves time and therefore cost during manufacturing. With fewer components to fail, it makes the overall motor and control system more reliable and durable compared to sensor-based systems. DCM Motion Technology enables a host of new control and monitoring possibilities which are not possible with the sensor-based systems used today. And finally, I would like to reveal here today that the first results we have from sensorless detection of AC/DC universal motors, which is the type commonly used in household appliances, look very promising. We believe sensorless transient detection is the optimum way to detect rotation in brushed DC motors and possibly also other commutating motor types. If you wish to obtain more information about sensorless transient detection and the control and monitoring opportunities offered by DCM Motion Technology, please go to our website www.IDEAdvance.com, where you can also find our contact details. Thank you for listening.